Howdy, AP PreCal. It's Ms. Cash. I am back doing more multiple choice questions to help you prepare for your AP exam. This is Unit 3. I don't remember the teacher that wrote this, so I apologize. I'm sorry. I should go back to Facebook and search for it and see who I can give credit to. So thank you for making this available. As with the other videos that I did for Mr. Passwater, I have not looked at these. So I'm walking in blind. You get to watch me think as we go. So the good news is that I love trig and polar. So hopefully things come easily for me. There were some in the Unit 2 where I was like, wait, what? Anyway, okay. So here we go. They're telling us an experiment in a science laboratory generates waves based on wind speed. The following data is collected for 32 seconds. Let V represent the wind speed for feet per second and T represent the time in seconds. Okay, so this is V and this is T. Write a sign equation that describes the wave. So what do we notice? I see something as low as 16 and as high as, so then what did I do to go from here? We added 24, and then I add another 24, then I subtract 24, and I subtract 24 again. Okay, so it sure looks like, well, oh, okay. I was going to say, it sure looks like we have an A value of 24 because we're, our midline would be here at 40. We started as low as 16. We go to 40. We go up to 64. We come back to 40. We go back to 16. So we have plus, so, right? This would be at, this is got a height there of 16, and this has a, or not a height, but anyway, a y value of 16, a y value of 64. Not really in this world, it's v of t, but okay. Then our period, it did everything it's going to do by 32, so 2 pi over b equals 32. So b is going to equal 2 pi over 32, which can reduce to pi over 16. Notice that takes out those two, but this is the only one that had that amplitude anyway. Minus 8 means that, because this was the point 0, 16, and then this was the point 8, 40. I knew from the very beginning, or not the very beginning, but pretty quick that this was the answer. I'm just verifying all the details. And so yes, it's scooted to the right 8, and then there's our shape. So its answer choice is B. On this one, I see a sine curve. Oh dear. Let's see. It looks like I got back to the top at 3 pi, and oh. Well, okay, let's look at something else. My poor little eyes. I see this is an amplitude of 3, so we can eliminate this one. I see that it's a sine curve, and then that doesn't help me. What do I notice? A period. So this would give me a period of 2 pi over 3. And so that means this is already 3 pi over 2, which is bigger. So it would have to do everything it's going to do by 2 pi over 3, so that's no good. This is going to have a period of 4 pi, maybe. Yeah, that seems reasonable. This could be back here at 4 pi. It could just be my eyes, you guys. This would have a period of pi. 2 pi over 2 is pi. This would be, pi would be, this is 1, 2, 3, so this would be, pi would be here. So no, that's no good. Okay, so despite my bad vision, that seems to be the answer. Okay, the phase shift, that's going to be pi over 4, and it's going to go to the right. Simplify. Okay, what would I do first? I would say, well, we can factor out a sine squared, leaving me with 1 plus cotangent squared. What I recognize is that this is probably an identity. I have the Big Daddy memorized. Remember how this one is so important? We nicknamed it the Big Daddy. And if I want to get cotangent, I have to have cotangent is cosine over sine. So if I come through and divide everybody by sine squared, I don't really have this memorized, but I know that 1 plus cotangent squared x is equal to cosecant squared x. So I have this part memorized. You can't help but have that memorized, and then I manipulate it to get what I want. So then this becomes sine squared times, well, cosecant squared is 1 over sine squared, which gives me 1. There are other ways to solve that problem, but we got there. Okay, so on this one, simplify the expression. So I have cosine, and then we're going to have to, then it's sine over cosine. We need this one to add fractions. We need a common denominator. So we're going to multiply by a funky form of 1. And this gives me a cosine squared plus a sine squared, well, sine and then a sine squared, but I'm going to put it in this order, plus sine over cosine x times 1 plus sine of x. Okay, where did I get all this? I'm sorry, I'm skipping a few steps to save space and go quick. Cosine times cosine is cosine squared. Sine times sine gives me that sine squared. Sine times 1 gives me sine. This, sine squared plus cosine squared, we just said was equal to 1. So I have 1 plus sine over cosine x times 1 plus sine. The numerator and the denominator divide out to give us 1, so then this equals 1 over cosine, which is secant. Fun. I love trig identities. They're my favorite. Okay, this one, sine of pi over 4. This is 2 times root 2 over 2 plus 3 times tangent of 3 pi over 4. 3 pi over 4 is here. The tangent value is a slope. It's negative 1. So this is root 2 minus 3. Is that an answer choice? It is. That was fun. Okay, what is the period and the amplitude of the current in this situation? The period is 2 pi over b, so 2 over 75. Okay, that's the only one. The amplitude is this value, so there we go. Cosine would normally start, okay, so the period is, the amplitude is 2, but we've been shifted down, so we need to have a range of -3 to 1. -3 to 1, that's fine. Oh, nope, -1 to 3 is no good. Nope, -1 to 3 is no good. -3 to 1, so we've already eliminated 2 of our choices. We then, cosine normally starts at the top, but then we shifted to the left. So, because it's plus, so we shifted to the left. Nope, that's not true. Right here, we normally would start at the top, but we shifted to the left. That's our answer choice. Okay, so find sine of theta if cosine is equal to 4 over 9 and tangent is less than 0. Oh, that's clever. So cosine is going to be positive. Where is cosine? So we want a quadrant where cosine is positive and tangent is negative. Okay, so we want, what did we just say? Cosine, we want to be positive. Tangent, we want to be that's not a negative. Negative. So some people remember all students take, which is a lie, but whatever. All students take calculus, so which tells us that what's positive, that all are positive here, and only sine is positive here, tangent is positive here, the other 2 are negative, and then cosine is positive here. So in this quadrant, cosine will be positive, but tangent will be negative. So we want to be over here, and we're going to say cosine is adjacent over hypotenuse. Always, always, always draw the hypotenuse from the origin and go from there. So what is this? 81 minus 16. 81 minus 6 is 75, so 65. So root 65, but it's going down, so let's make it negative. So the sign is going to be negative 65 over 9. That was a fun problem too. I liked it. I like trig so much, you guys. It's so fun. Okay, amplitude. Amplitude is not negative. The A value can be negative, but the amplitude won't be negative. So there go those. The period is 2 pi over b, which was 3. Okay, that didn't help us. The phase shift, we're moving to the right pi over. Oh, that's clever. So what he did here is he wrote a problem where he had factored it out, but gave us the option with it not factored out. But when it's factored out, you can see the phase shift. So that was good. Okay, find tangent if sine is this and cosine is that. Well, okay, here's one way to do that. Tangent, I could draw the triangle, and that's what I'm used to doing, but they don't usually give me both. But we know that tangent is sine over cosine. Okay, so the sine value is negative 5, 6. We're dividing by the cosine value, which is root 11 over 6. How do I divide fractions? I multiply by the reciprocal. I do not know what just came out of my mouth. That sounded very southern. I'm Texan, but goodness gracious, where did that come from? We can multiply by a funky form of 1 and get negative 5 root 11 over 11. There we go. Okay, find the exact value of the expression. Okay, so the inverse, okay, so this is saying, find the cosine of an angle whose sine is this. Notice they're all positive, so we'll just assume we're in quadrant 1. So the sine is 24 over 25. This is a 724-25 triangle, which is one of the triples that we have memorized. What is cosine of this angle? 7 over 25. There we go. For what numbers is secant undefined? Well, so one way to think about this is that secant of x is equal to 1 over cosine. You are not Chuck Norris. You cannot divide by 0. When does cosine equal 0? At pi over 2 plus pi k. Okay, so that would be this one. This is the pi over 4 family. This is not. Okay, there we go. Which transformation was not performed? Oh, that's clever. Okay, so it's a shift, a horizontal shift. Yes, that's true. A horizontal dilation by a factor. I think it's a dilation by a factor of 1/2. So I'm guessing a reflection across, deflection through the x-axis. Yes, right there. Vertical dilation by a factor of 3. Yes, right there. So it's actually a horizontal dilation by a factor of 1/2. Because it used to have a period of 2 pi, and now it has a period of just pi because it's 2 pi over 2, which is pi. For which values does cotangent have vertical asymptotes? Okay, keep in mind cotangent is equal to cosine over sine, so it has asymptotes wherever you're not Chuck Norris, you can't divide by 0. Where does sine have zeros? Sine has zeros at pi k. So at 0, so it's going to be a negative 2 pi, negative pi, a 0, pi, and 2 pi, which is right here. Y'all, these are fun. Don't you enjoy this? I hope you do. Okay, here we have a cosine squared factored out, and then this is the big daddy. So we have cosine squared times cosine squared, which is cosine to the 4th. Here we go. We're going to solve for cosine. So we're going to add root 3, divide by 2. This is unit circle friendly. We have gone over a lot. So this is 1 pi over 6 and 11 pi over 6. And that's here. And how long is my video? Oh, well, maybe I'll do this page and then let you go practice. Okay, so let's see. Find the inverse. Ooh. Sorry. Can I amuse myself? Is that allowed? I would probably come in here and change my x and y's. I would add 3 and divide by 9. And now we need to take arc sine of both sides. So it's, well, sine to the negative 1. It's the inverse sine of this. X plus 3 over 9 is equal to our y value. X plus 9 over 3. Nope. X plus 3 over 9. Yep. It's not, that's clever to try and mess with you, but no. This one all of a sudden looks scary until all of a sudden you realize that they're just saying, what's the inverse sine of negative 1/2? Well, keep in mind, inverse sine is different than saying, this is a different question than saying sine of what equals negative 1/2. They behave in a similar way, but they are not the same. This is saying we have a function that's going to have exactly one answer to this problem. Just like if I say, what's the square root of 16? It's exactly 4. But if I say x squared equals 16, can you see what I'm doing? I can take the square root of both sides, and I can do square root plus minus, and I get x equals plus or minus 4. This question has just one answer. This has 2. This has infinitely many. This has exactly one answer. So keep in mind, sine, inverse sine, arc sine, lives in quadrants 1 and 4, going from negative pi over 2 to a positive pi over 2. So if I want to have a negative 1/2, that means I went down a little. That's a negative pi over 6 is the only answer for that. This has infinitely many answers. It has anything coterminal with this one, but it also has anything coterminal over here. So they are not the same question. Be careful with that. It only has this answer. And if I had wanted to be sneaky, what I would have put as a multiple choice is my answer choices, I probably would have thrown in an 11 pi over 6 because it's coterminal to that, but it's not, this is not the answer. You have to, inverse sine can only give you answers between negative pi over 2 and positive pi over 2. So while this one is coterminal here, it's not going to be the right answer. I probably, if I had written this multiple choice question, because I'm not a nice person, I would have included this one, this one, this one, and I would have probably said negative pi over 3, well, maybe not, maybe thrown in a 5 pi over 6, thinking maybe you'd think it was cosine. Okay. Oh, this was nice that they did that. I don't always tell you how to split it apart. But this is a sine, cosine, cosine, sine is how I remember this. So sine of pi over 4 minus pi over 6 is going to be equal to sine, cosine, cosine, sine, pi over 4, pi over 6, pi over 4, pi over 6 with the same SIGN is how I remember that. The sine one is sine, cosine, cosine, sine with the same SIGN. Sine, this is root 2 over 2. Cosine of pi over 6, I went out a lot, so that's root 3 over 2. Cosine, root 2 over 2. Sine, we went up a little. Okay, so it's root 6 minus root 2. Oh, no, not over 2. 2 times 2 is 4. There we go. They almost caught me. Same idea with this one, except the cosine formula. I don't want to work this one, but just remember, cosine of 5 pi over 3 minus 3 pi over 4 is going to be, the cosine one is cosine. Well, it's cosine, cosine, sine, sine with the opposite SIGN. So it would be something like that. And now we can evaluate it, and I just don't feel like it. All right, come back. I will keep working some problems here. And yeah, like, subscribe, comment, all the things, and let me know how I can help you. Study hard.